just for the video here. Okay, so I'm going to speak in the microphone really quick. All right, for any students missing this, this is our warm-up. We just started. Okay. All right, anybody need more time? Yeah, a little bit more time. You guys like another minute to figure this out? And we're missing Luke. And who else? Is that it?
Molly.
Oh, Molly's not going to be in this class either. Nothing. Oh, she's a new student here, but she's going to enroll in a different math class right now. Yeah, she's a new student here, and she's actually, I think, like a amateur or aspiring professional surfer. So, yeah, that's why she was like a super tan and a very bleached hair, because she's always out in the water. It's kind of cool when I meet like professional athletes and stuff or something. Such as yourself, Shamaria. You guys can teach me a lot. Hey, look, we're just starting on this warm-up right now. Okay. And now we're just about to go over it. Okay, anybody need more help? Or need more time, I mean? A little bit more time? Okay, we're going to begin right now. So you can either keep going or you can stop where you are because we're going to go over it together, okay? I would say the easiest one to tackle. Actually, which one did you try tackling first? X or Y? Which one did you guys try? You tried Y?
No.
Oh, all right.
Oh, wait, no, sorry. I was just talking to myself.
Oh, okay. All right. Fair enough. Anybody try going for any of these? X or Y? No?
X.
Yeah? Yeah?
X.
Oh, you went for X. Why did you go for X, or how did you, I don't know. Like, what did you see in X?
I just thought it would be the easiest.
Okay. And then why is that? Like, what can we do with X? How did you even set up to solve for X?
I said x plus b plus a equals 180.
Okay, because all angles on the inside of a triangle add up to what? 180 degrees. So if I had to write this formally, I would say angle, the measure, okay? So when we talk about numbers and angles, we talk about the measure of angle A plus the measure of angle B plus the measure of angle X is supposed to equal what? All three of these angles are supposed to add up to 180. So I could substitute in values for A and B, can't I? Because A says explicitly right there it's equal to 30 degrees. How about B? 72. Sorry, that should have been 72. And this measure of angle X is, I don't know it, so I'll leave it like as one giant variable for me to solve for, okay? E is equal to 180. If I combine like terms, what is 30 plus 72 to save myself some work or some confusion? 102 plus the measure of X, so I still don't know what X is, equals 180. And then now what? What do I do now at this step? I'll tell you. You subtract 102 from both sides. And then the measure of angle X should be 180 minus, what is it, 102? What is that? 78, yeah, it is. It's 78 degrees. So we found the measure of X is 78 degrees. Okay, so there you go. You have 78 degrees. What about Y? What do I know about Y? If I took a straight line, okay, and I made many angles out of it. You guys see there's one angle here and one angle here now? I made like a bunch of different angles. All the angles, though, have to add up to what? 180 degrees. So if I look at X and Y, are they on a straight line? So if I know that there's only two angles, X and Y, what can I do with my new value, 78 degrees, and Y? To solve for Y, I mean. What do you suppose I should do now? Yeah, Natalie?
78 degrees plus y equals...
Yeah. So I could say, if I want to write it more formally, I could write this is like one formal thing here to solve for X. And on the bottom, I could say the measure of X plus the measure of Y is equal to what again, Natalie? 180 degrees. And I know that X is equal to 78 plus the measure of angle Y is equal to 180. So I subtract 78 from both sides, and then I should get a very familiar number, which is 102. 102 degrees. Okay, so there we are. let's make some relationships here as you guys are writing this down. Because we will kind of use this to our advantage to understand these things, okay? If you look back really quick, where else do you see 102? Why does that seem so familiar? That the measure of angle y is equal to 102. Somewhere on this paper, we've already seen that number before. Yeah?
When you add 72 and 30.
When you add 72 and 30, which are which angles? A and B. What do you notice the relationship between? Oh, does anybody remember what this angle is called if it's on the outside of your triangle? It's not on the interior, but what is it? The exterior. So we call an exterior angle. And if you remember back, there's something called the exterior angles theorem. And what that said was your two opposite angles should add up to your exterior angle. If you look closely, is that not what happened? A and B added to what? 102, right? What did we end up finding for Y? It was, huh? It was also 102. So we had multiple ways to solve for this. One thing, though, that I want you to kind of think about. If I compare just A to Y, who's bigger? Without even knowing the math, who ends up being bigger? Y, right? Because you know Y is a combination of both. How about B? When you compare B to Y, who's going to be bigger? What if I never gave you the values? Would you be able to tell me that? Because you know that these two combined make up Y, right? So there's no way individually they could be bigger than Y, right? That's going to be the first theorem that you learned about today. And you saw that exactly. You did math to see that this angle on the outside is always going to be bigger than the two opposite angles because these two have to add together to make him up, right? Well, that's where we're going to get into 7-3 inequalities in one triangle. Hey, Zane, come on in. So I wrote down the title, Inequalities in One Triangle. And then here's the first theory that you're going to see. I know it's kind of hard to see, but measure of angle 1 is an interior angle or an exterior angle. By looking at it, what is it? It's an exterior angle. So can you tell me which angles on this triangle should be smaller than measure of angle 1? Is it A, B, or C?
All of them?
Well, C, I don't know, but yeah, go ahead.
A or B?
A or B, right? Because they're opposite, right?
I also thought that angle C and angle 1 were kind of vertical. Like,
Kind of vertical, but that
So that's that would what that's why.
it looks like it. So this though is not completely vertical, right? Watch this though. What if this is like a line that's not, sorry about that. This is like a line that kind of hits this line, right? This line and this line, right? It's not completely vertical unless it completely crosses. Now, do you see? Now we have, you see where my chin is here, this angle here, and then this angle down here. They're vertical now, but they're not vertical if it's only like halfway. That's what you see here. So in order for this angle to be vertical, this line has to continue straight forward. Now do you see the two vertical angles? It's like here and here, okay? So they're not quite vertical yet, okay? So this is simple now. Now we know that A and B add up to 1, but they can never be bigger than 1. It even says right there. You said C as well, though, right? You said C looks smaller, correct?
I thought C was on the inside.
It is. C is on the inside. 1 is on the outside. C is on the inside, okay? But don't ever trust the drawing, because even though it looks like it could be bigger, it could be a situation where, because right now you have this triangle like this, right? A straight line. And then it looks like 1 is a bigger angle than C, right? But remember, don't ever trust the drawing because we don't know if it might be actually that or it could be. Let me give you another example here. Here's 1 and here's C. Now who's bigger? See? No pun intended. Do you see now? Like, now this is a situation where the exterior angle, it's still bigger than these two angles here and here. But there is a situation where 1 could be bigger than C. Okay? So that's why this theorem says only C could be bigger, or I'm sorry, 1 can only be bigger in the opposite angles. We don't know about the angle that it's right next to because it might not always be bigger. Okay? So with that being said, let's take a look at our problem, shall we? Oh, I believe I forgot to put up a cheat sheet for this. There should be a cheat sheet for this, okay? But if I forget to put one up for 7.3 and 7.5, okay, you can make your own for the exam with this theorem. So this is a theorem. Maybe write it down somewhere in your notes that you might want to write this as a theorem. This is in page 400, around 427, okay? You can write this down in your own sheet of notes. You don't have to write it right now. Just make sure you take note. This is page 427. You could write this down when you get home. Okay, so let's look at a problem right now. Let's copy down a problem. So here is let me see. Here's an example. Here's a triangle that we're going to draw. Draw a straight horizontal line going to the right. And then we're going to have another arrow going down at an angle, sort of, right there. And then we're going to draw the tip of the arrow up here, the vertical or the horizontal arrow at the top, to somewhere below where it hits the other line, but not, not the ends, but right there, just at some point. Okay. We're going to call those points J and K. And then we're going to say that this is L, right? And then from K, the corner of K, we're just going to hit somewhere in the middle. It doesn't have to be in the middle of J and L. All right. Those are going to be the points J, K, L, and M. And then with my other pen, you don't have to have a different colored pen, but I'm going to go ahead and use one. I'm going to write in the angles. Angle 1, angle 2, angle 3, 4, 5, and 6. And there's one more on the outside. There is angle 7. What I want you to do is to find out with me right now. Let's discuss. Any measure of angle. Let's see. I want you to find measures less than, that are smaller than measure of angle 7. Okay? This is your task now with you and a partner. Find some angles that are less than measure of angle 7 using that theory we just talked about, okay? All right, let's talk about it for about 3 minutes or so, okay? Which angles can you find that are smaller than angle 7? So go. Try figuring this one out. This one's not too bad, but could be pretty hard.
So is angle 6 congruent to angle 1?
No, you cannot say that. Use only the theory I showed you earlier, where the exterior angle is bigger than the opposite interior angles.
So that
Anybody having any problems with this one or no? I'll say this. Measure of angle 7 is bigger than 4 angles for sure. That's your clue. I'll give you guys like another minute. What do you think, Luke?
It's too smaller than
Huh?
Wait, we're looking for smaller angles.
Mhm.
Is it too smaller than the angles?
How did you know 2 was?
Because like 7 is wider and 2 kind of.
Well, that's what it looks like. It totally does. And you're actually right that it will end up being smaller. But you got to use the angle theorem that we talked about. That this So let me pause this for a second, okay? And this over here, this theory says that this exterior angle on the outside is bigger than the two inner angles opposite away from it, okay? This angle 7 is on the outside. Who are the two angles opposite of it? Be careful, there's two triangles. There's this large triangle and then there's this small triangle. Which triangle would it be?
Sorry, no, I was looking at the.
Oh, actually, yeah. Well, okay, so if we look at 1, 2, and 3, just pretend for a second that line isn't there. Can you see, like, pretend that line never cut the 2 and 4 together. Who is 7 bigger than now? This guy, for sure. So he's bigger than angle 1. Who else?
Without the line being,
Uh-huh.
he's still bigger than everything else.
So what is everything else? What if this was one giant angle? Is it still bigger? Like, what if this wasn't 2 and 4? What would it be? It would just be like A. Let's just call that angle A. Is it bigger than angle A?
Yes.
It is. If it's bigger than 2 and 4 combined, don't you think it'd be bigger than 2 by itself? Yeah, definitely, right? How about this one? What if now we looked at this triangle? Is it still exterior to these two angles? It is. It is exterior. So now who's it bigger than? 5. So which ones we have? 1. Well, remember, I told you that be careful. You see in the upper left-hand corner, it's only guaranteed that it's bigger than 1. Here. What else?
I mean, if this right here, 2 and 4.
2 and 4, both. Yeah. And one more. You got one.
3 and 2.
Well,
5 and 8.
So once you have this here, you just have this triangle. 3's not included in the picture here.
It's bigger than
Not 6 though. Okay. Again, it looks like it's by picture, but only use the theorem. Okay. Because if you go by the picture, it could be wrong. Like, it could be like the guy's like, "Well, I meant to draw." So, I mean, he could be completely wrong here. So you need to only go by the theorem that guarantees that the exterior is small. Okay. All right. Did you guys get any angles that are bigger or smaller? I'm sorry, or that are smaller than 7? Anybody? Anybody want to go for one?
We've got 2, 3, 4, and 5 are less than measure angle 7.
2, 3, 4, and 5. Okay, so let's back up a second. How did you get 2? Remember, you can't go by looks. You can't go by the way it looks. You have to use the theorem. So, did anybody get 2? No? Yes? Okay, how did you get 3, 4, or 5? Again, did you only go by looks or did you go by the theorem? So this one's tricky, isn't it? Because you see, how many triangles do we see in here? I see 3. All right, so show me the first one. Where's the first one? Okay, I got 1, 2, and 3 is another one triangle, right? Then 4, 5, and 6, like Luke's saying, is another triangle. How about one more triangle?
The whole triangle.
The whole big triangle, right? Now hold on. We notice that 7 is exterior, right? Is on the outside of which two triangles though? How about, is it exterior to this triangle here?
I can't see.
Oh, guys, I'm so sorry. Here's one triangle. Here's another triangle, 1, 2, 3, right? And then the big triangle. Everybody see that now? 7 is on the exterior, on the outside of this one. Is it? Is it directly touching it and on the outside of 4? Okay. How about this triangle? Is it exterior to these two triangles? It is not. It's not connected to it at all, right? How about the giant triangle? Okay. Now that we've identified who's it's exterior to, who are the two opposite triangle, or who are the two opposite angles on this triangle here from 7? Is it 5, 4, or 6? Which ones are opposite and away from 7?
4 and 5.
4 and 5. So by the theory, measure of angle 7 is greater than, so far we know, the measure of angle 5, comma, the measure of angle 4. Okay? Just by the theory, right? Okay, what else though? There's 2 more angles. This one's pretty tricky. So let's see. Do I need to worry about this third triangle? 1, 2, and 3.
No.
I don't, because it's not exterior to those. How about the big giant triangle? Ow. The big giant triangle. The overall big triangle. Is 7 exterior on the outside of the big triangle now? Okay. Now remember, if I said the big triangle, try to imagine that that line is not there. Okay. Now do we see that it's exterior to this giant big triangle here? What angle is now away from 7? That is opposite to 7. That's directly touching it, so it's not opposite in a way. Huh? So what can we say about measure of angle 7 compared to 1? Who's bigger? 7 is definitely bigger than the measure of angle 1. The question is, what the heck do I call this angle in the corner? Because there's not one angle assigned to it, right? So let's just call that angle K, right? We know that the measure of 7, angle 7, is bigger than all of this, the measure of angle K, right? 2 and 4, right? Which is bigger than the measure of angle K. If I had to rewrite this, I would rewrite it like this. The measure of angle 7 is greater than the measure of angle. Which 2 angles make up K? 2 and 4. 2 plus 4, right? And we already know that it's already bigger than 4, right? Would it be weird to say that if I knew that measure of angle 1 was bigger than both of these combined, it's also bigger than just the measure of angle 2 as well? Does that make sense? It's like saying this. If you knew that 4 was bigger than 2 plus 1, couldn't you still say 4 is greater than 2 by itself? Yeah? And could you also say 4 is still greater than 1 by itself? So it's like saying this. It's like up here, I said that, you don't have to know that. The measure of angle 2 is greater than, or the measure of angle 7 is greater than the measure of angle 2 plus 4. It's also just bigger than the measure of angle 2, okay? So those are the 4 angles. Measure of angle 7 is bigger than these 3 angles here and this angle, right? You guys want to try another one? I know you do. I know you do. I don't have my book, so I can't do that. Oh, thank you, sir. Thank you, Mr. Okay. I'm going to give you another one. Okay. Let's see. I'm going to give you this triangle. You don't have to draw this one. Right. Just 1A. Can you please tell me 1A, which measures are less than the measure of angle 1? Okay, so go ahead and begin. Actually, go up on the board and give me your answers now, all right? You don't have to draw the triangle. You just need to list out the angles that you think are smaller than 1. Yeah, go ahead and sign in, Luke. And then Zane, you're going to work with Luke today, okay?
Whoa.
Yeah, go ahead. Sneak preview for your future lessons. Sneak preview. Yeah, you can grab whatever you like. Yep, and just put it on that table and go to work. Okay, so your goal, there are 4 angles that are smaller than measure of angle 1. You don't have to do any of the math like I did. You just have to kind of figure it out, right? There are 4 guaranteed angles.
So there are only 4, or
There are only 4, guaranteed. Again, don't ever go by the looks. Just go with the theorem.
Angle 5 is less. No, I think angle 6 is
Both of what, Lena?
Or the angles.
Which angles?
6.
Yeah, you're good. You got it. You got it.
And angle 2. Angle 2.
Some of these can get really tricky in your homework. Okay, so come and see me if you need help with these last sections.
Angle 3. Yeah.
So you get 5, 6, 3, and 4. And what else did you get? 2 as well. Right. Ah, you had him. Why you take him away?
It felt wrong.
Don't. Just because it feels wrong doesn't mean it is wrong. Shamaria, come on. Okay. Anyone need a little bit more time? You got him? Okay. You guys ready? You guys want to see the reveal? Ah! Don't worry about 1B, just 1A. 3, 4, 5, and 6. Okay. Alina and Natalie, I heard you guys talking that it's both 5 and 6. How did you know that? I
They
don't.
visually look smaller than angle 1.
Don't go by visual, okay? So why is it that 1 is greater than 5 and 6? Okay, again, you guys can never go by the visual. Always go by the theory, right? Anybody else want to tell me how they got 3, 4, or 5, or 6? First off, yeah, go ahead, Z.
that thing that you just did, where if you look at it as a whole triangle, you know that angle R is smaller than 1, so then you know 4 or 6 and 5 are smaller.
Okay, so hold on. You guys see the big triangle? It's like Zane's ignoring that little triangle there. Does everybody see that? So, whoops. I don't need an autofocus. All right, that's as far as I can zoom in. Here, if you can see this large triangle, 1 is exterior to, 1 is bigger than 2 angles in the corners. Angle Q and angle R, right? 1 is greater than Q and R, right? So if we looked at it this way, 3 and 4 combine to make Q. But even when they're combined, they're not bigger than 1, right? So guess what? 1 is greater than both 3 and 4, okay? 1 is also opposite of the exterior angle 1 is this large angle R, the 2 angles in the corner. Again, 5 and 6 combined are smaller than 1. So individually, 1 is definitely greater than 5 and 6. Does that make sense? So that's how you guys should have gone 3, 4, 5, and 6. Even though 1 looks visually bigger than 7, I'm really happy that no one picked 7, okay? Because remember, there's no theory that says anything about a little triangle angle in the middle there. And then the 1's going to be bigger than that, okay? It only says that the exterior angle is greater than the 2 corners that's opposite to. And each corner, both of these angles were, both 3 and 4 and 5 and 6 were both locked into the corners here, making 1 bigger than all of them, okay? Now, what I want you to do is draw a scalene triangle. Talk to each other about what a scalene triangle is. A big one. Draw a big one. A big scalene triangle. I want 3 completely different sides, all right? Okay. That's yours too. You took over. All right. Can you label your angles now? You can do 1, 2, and 3, whatever angle. Go ahead. A, B, C, Matthew, Frederick, and Elisa. I don't know. Call them whatever you want.
Oh, I thought he was still that.
Yeah. I'd be going senile. Matthew, my name is Zane, but all right. Okay. And then why don't we call our lines something? Go ahead and name your lines. You don't have to do like A, B or something like that. You can just name it whatever part. Tom, line Tom. So Zane's going by Tom. He's naming his sides by actual names. Tim, Tom, and Tim Toms and Timothy. Okay, all right. I would hate to be that child in that brotherhood. My first brother's literally named Tim. Why couldn't you call me something different than Timothy? But it's fine. Potter Neasley or Weasley? I like Neasley. That's cool. But Weasley. I know it's Weasley. Hey, and Granger. Oh, it's Harry Potter characters, right?
Yeah.
Potter. Yeah. Potter. Yeah, I remember. Okay. All right. Now, please put in order from shortest to biggest your angles and your sides. Just write it somewhere. Right?
Shortest to biggest.
Yeah, like write it as a sentence. Like Timothy, comma Tim, comma. I actually like the way that you're doing it, Luke. Yeah, so go ahead and do that. Yeah. Wait. So Natalie and Alina, look how they're doing it. They're putting like in a different colored pen. They're saying this is the middle or something. Second smallest, however you want. I want you to do it to both the angles and the sides.
So then 2 would be the largest.
The hard part's the angle, but just look at it visually. This one I'll let you do just by visual, what you see. It's kind of hard to see for some people.
That one would be small.
You don't have to name them. You can just do whatever you want. 1, 2, 3. Are you guys having problems with defining which ones are bigger?
No, the angles, not like the
Oh, okay. But you figured out which ones are bigger.
sides.
Okay. All right, guys. Now, please locate the smallest angle and the smallest side, where they are, in relation to each other. Okay.
Wait, just like hand them out? Or?
No. Don't do anything now. Just look at them visually and just look where they are. How about the middle angle and the middle side? Look at where in relation where they are to each other. And look at the biggest and the biggest. What do you guys notice? Is there any weird relationship between the biggest angle and the biggest side, the smallest angle on the smallest side, and the medium angle on the medium side? Yeah. Come on, Alina. So go ahead, Alina. Let's listen to Alina. No pressure on Alina, okay? What'd you say? The smallest angle has, or the
Small side has the biggest angle.
smallest side has a smaller.
The biggest angle.
Does it? Oh, it contains the biggest angle. Okay. How about this? What do you guys notice about this? The largest side and the largest angle. Where are they in relation to each other?
They're opposites.
They're kind of opposite, right? How about the smallest angle and what they call the smallest side? Look on your triangle. Is that what it's happening?
Yeah.
And then how about the second largest angle and the second largest side? On your triangle, are they opposite away from each other?
Yeah.
How about yours, David?
Kind of. Yeah.
How about yours, Shamaria? Yes, right, because it's the same triangle. Okay. All right. You can have a seat now. This is literally a theory. We had 3 different triangles, and yet they still followed the same theory. None of them broke this rule. It's literally called an angle side inequality. In other words, if you have the longest side, it's opposite to your largest angle. If you have the shortest side, it's opposite of your smallest angle. And if you have your medium side, it's going to be opposite of your medium angle, right? They're the exact same relationship no matter which triangle you drew. It's always going to hold the same way. Okay? So this is another theorem that you must know, but you might not even have to memorize it. You just know it, right? You can just tell now, okay? So let's see. Let's try this example together. Judging by the angle or the side lengths, which angle is going to be the smallest on this triangle here? Is it going to be angle P, Q, or R?
Because it's opposite the smallest.
Okay, so you say Q? Okay, how about the medium angle? Where's the medium angle? P, Q, or R? Okay, and then who do you think is going to have the biggest angle? Okay, so let's see. List the angles of PQR in order from smallest to largest. It is indeed Q is the smallest, R, and P. Not bad. Not bad at all. Let's see. Let's see if I can get it even a little bit trickier now. Can I go even trickier? Let's see. I guess we'll just stop there, I guess. Yeah, I don't know. Oh, here. Ooh, how about this one? Number 6. How about the sides?
And
First, though, what is angle K? Anybody know how to do? I mean, we have J and L, but how are we going to solve for K first? We need to solve for K.
47 degrees.
Okay, first off, how did you get 47 degrees?
46 plus 87 and then subtract it from 180.
Okay, because all triangles have to add up to 180 degrees. So if I subtracted 46 and 87 from 180, what would you supposedly get for K? Luke, did you do it too? Someone doing the math right now to figure this out?
47.
Okay, so K is, can anybody confirm that it's 47?
Yeah, 27.
It's 47? Okay, so which side should be the smallest then?
Okay.
See, Natalie, did you get that as well? So which angle did you get for K? How big was your angle? Okay, so let's say it's 47, okay? Which side looks to be the biggest though, Natalie?
Angle L.
Or the side.
Oh.
Like LK, JL, or JK.
JK.
Oh, it does, huh? It does. Or how about second biggest then?
J and L and L and K, kind of.
Kind of, right? Well, just by our numbers, this is 47, 46, and 87. Who for sure is our smallest?
L.
What is it?
No.
No, the smallest sides. So this is 46 angle. This angle in the corner here is 47. This is 87. Who should be the smallest side? It should be LK. That's correct. Because it's opposite away from the smallest angle. Who is our biggest side for sure? JK, not just by the look, but because it's opposite away from the biggest angle, which is 87 degrees. K, remember, is 47. So who is going to be the second biggest side? It should be JL. And you said too, Natalie, that JL and KL look about the same, right? Their angle measures are also very much similar, 46 and 47.
Like 1 degree different.
1 degree different. So it's really hard to tell their sides opposite are going to be any bigger as well. Okay. So just to kind of give you an idea, if your angles aren't that much different, your sides aren't going to be that much different either. Okay. All right. So there we are. JKL in order from smallest to biggest in terms of angles. In terms of sides, it's going to be KL is going to be the smallest. JL is going to be second smallest because that's opposite of 47 degrees. And JK is going to be the biggest. All right. Any questions on that so far? Okay, let's move on to 7-5. So why don't you get your notes ready for 7-5. I'm skipping ahead now. Okay, no 7-4. I think that is pretty tough here. Okay. Read this theory here. Try to figure out what it's saying. And then I'm going to draw a triangle that goes with this theorem. Okay? Anybody understand what that triangle theorem is saying? This is on 7-5. What is this theory saying? Is it hard to understand what's going on? No? All right. Actually, I'm going to draw it on another piece of paper, okay? So that way I can get it on video. According to this theory, I should get a triangle that looks like this. Let's see. Let's see if this works, okay? Actually, let's do this. Let's do an even more complicated triangle here. Let's see. This is 15, 16, and 30. So let's say this is 15, 16, and 30 inches, okay? This triangle is 15, 16, and 30 inches. What is this theorem saying here? What does this theory say? Does anybody catch that? Can anybody summarize what this theorem is saying? Yes, Natalie.
I don't know if you heard that, but two of the angles of the measures are bigger than the third angle
Is it angles or sides?
sides.
So any two sides add together should be bigger than the third side, right? This is a triangle that is real, confirmed, okay? Let's see if that's true. So theoretically, this side and this side together should be bigger than the third side. Is it? How do we know? How do we check? Well, to do this, we combine both sides. We just add 15 and 16 together. And let's see if it's equal to or greater than 30. What is 15 plus 16? Is it indeed greater than that third side? Okay, good. So far, that looks good. It has to work with every other combination of sides. How about this small side and this large side? Is it going to be bigger than the third side? 15 plus 30. Will that be bigger than 16? Yes or no? Do you even need to do the math to figure that out? Because you already see that 30 is going to be bigger than 16 for sure. So you don't even have to check. That's just going to be bigger. But if you wanted to, it's 45. Yeah, for sure, it's going to be greater than 16. How about the other two sides, 16 and 30? Is 16 plus 30 going to be greater than 15?
16 is greater than 15.
Yeah, 16 is already greater than 15. I don't even need to do this at all. But if you had to see it, yeah, it's 46 minus 15. That makes a real triangle. What if that doesn't happen, though? What if we have three sides that don't follow that? Like, how about 3, 3, and 6? How about this? 3 and 3, is that going to be greater than 6?
No.
So it's equal to 6. What do you think is going to happen? Is it going to be even a triangle? Notice the way I drew it. What's going to happen to my triangle?
Maybe a false triangle.
It's going to be a false triangle, but are they even going to connect? So that's the point. You might draw something that either looks like this, where it overlaps and is not a triangle, or it looks like this. There's one side that's incomplete. It's not long enough to close, okay? If you do not have this checked out, you will have incomplete triangles that don't fully close and don't fully connect. Does that make sense? All right, so that's going to be your theory. This is the main theory for 7-5. Was that not easy to understand? Just add two sides together and see if the other side is bigger, right? Let's double check. So let's try a problem, okay? So this is why I like these sections. I think they're a little bit easier than what we've done before. There's no proofs. Well, there is one proof at the end. I'm so sorry. There is one proof at the end, okay? This is going to be the triangle inequality, 7-5. And let's just double check right now for an example. Check to see if the following, I'm going to zoom out, following side lengths will form a triangle. So here's the first one. I want you to double check this. Please do this on the board right now. See if this will give you a proper triangle with these side lines. 8 inches, 15 inches, 17, 10 inches. Please work together now and please solve for this.
Let's do this. I do like this.
Come on, Sienna. You got this, Sienna.
8 inches.
Show us your grit. Show us your strength. You got this.
So 8, sure. I'll be 8.
So how would you do this?
17,
Where do you start?
15. That's definitely longer. Yeah.
So what do
You
you
do a label on the side. So this is 8 inches.
The bottom.
17.
Because it's going at an angle. So sometimes if this was any longer, like it would keep going.
Okay, all right. Well, there's an easier way to check. Just see if two of the other sides are always bigger than the other side.
So yeah, it is. So 17 plus.
Okay. Well, let's just double check.
So
8.
17
So let me
plus-
try this. Okay. So Zane, what did you end up doing?
I just added this to this,
Be
this to this,
25.
and that to that.
Oh, wait, hold on. So you had 8 and 17 and 15. right?
25.
Now we have to check that 8 and 17 combined will be bigger than the third side.
Yeah, this is greater than.
Okay. So that's one check. Now we have to check every single combination. What's another combination?
Just you. 13 or bigger.
Yeah.
What is 8 plus 15? You can do it on the board. You can do it on the board.
23.
Is that bigger than 17?
Yeah.
Okay. And what's the last combination that I didn't do yet?
Wait, it's 25.
So
15.
Oh, yeah, it's true. 17.
Oh.
So is this a triangle?
Okay, so 8 is added with 17 and 8.
Mr. Weed,
Yeah.
so if one side is longer, couldn't you just make the opposite angle just steeper and that would equal?
Then no change the side.
5 is 12.
I mean, like if you just rotate it, like if you don't change the side line.
What do you mean?
So like, if you had like a swivel and it was like
So I do
this, if you just make this one equal by making this
It's abstract.
more like this.
Yeah, but what will happen is if you change the angle.
Oh, it's slightly changed.
No, you're right. If you shift this down, what would happen though is you would have one side far too bigger than the other. That would make it inside.
Kind of like this angle, if you were like rotating.
Yeah, the shortest angle. So what do you mean? This whole thing?
Yeah, like just this angle, like that one, bigger angle.
So you'd have this. You're just open up the angle even more like this. You're shifting it open. See?
But if you look this one and this one, like this, if there's bigger than angles.
So you would shift this.
It's like if you have.
Like, what are you asking me to do?
So you try to find it. And then you got the sticks. I'm gonna take this. Can I get the sticks?
Okay, very good. David, very good.
It's only one. So we're just gonna do like this one. So if you have like this and it doesn't fit, then you could do like this.
You just did it yourself. What happens?
So like if it's like this and it's, let's say this is 20, and so it goes like this and it doesn't work. Then you could just go like this and it work at 20.
Yeah, but you're changing the sideline. See, it's no
I'm
longer
saying if it
20.
was, if it's always at 20, because I can't discount. So if you do like this, if this is still 20, this is 1 pencil, this is 2 pencils.
Then
Does it
look, it
connect?
doesn't connect.
But then if you move it, it's the same length.
Oh, I see what you're saying. If you shift it up. Yeah, it's true. Oh,
I
let's
mean, if
see.
there's no, if it doesn't give an angle.
Because right here, let's see. There's no given angle. Let me see.
If there's an angle, it'd be good, and obviously.
Yeah, but then you would have an incomplete side length. That's just an ambiguous side length. So it just depends. Yeah, if I'm asking you to try to connect three sides, then yeah, they're gonna end up connecting. Do you see what I'm saying? But if you have like a length shorter, yeah, that's a odd question. But the thing, yeah, it does make sense though what you're asking me. But at that point, you have three side lengths that are able to do that. Then you have a triangle. There's no ambiguity here. But I guess yeah. I guess what you're saying is all three sides, as long as they have some kind of given angle, they should be connected to a triangle. That's true. Yeah, that is true. It's odd. I don't know how to. But I guess even if they did connect, if you had three side lengths, no matter what triangle you make, it's always going to follow that law that those two are always going to be bigger than the third side. So it doesn't really matter.
I mean, like, it's true, but there also isn't.
No, there's no exceptions.
Oh, wait.
Whatever
it's always true, but
No, whatever triangle you end up creating, even if you change the angle, the third side's always going to be smaller than the other sides, no matter if you change it or not. So I just don't understand how we got to that point where we're talking about. So I guess you're saying if you had a scenario where you had two sides that were not greater than the third side, could they still connect if you change the angle? I'd say even if you create, like you ended up creating that triangle, it would still follow that law with the two sides, where the two side lengths are greater than the third length, no matter what. Yeah, it's always going to follow that law. Yeah, no matter how much you shift it, as long as it creates a triangle, that third side's always going to be smaller.
That makes sense.
I don't know if it completely answers your question because I'm a little bit ambiguous too in that. But no matter what, at the end of the day, your triangle is always going to follow that law. Okay, so that one's good. And okay, we're going to move on. I was going to do one that didn't end up making a triangle, but we're going to move on to another question. And then we have a proof that we need to go through. Okay. So here we're going to make finding. Oops, sorry about that. Okay. If you can zoom in on here. This would be finding possible okay. Whoa, sorry about that. Come on. Okay. That didn't do the trick. There we are. If the measures of two sides, so think about this as you're writing, are 3 feet. So you have a 3-foot side and another side that's 7 foot. And 7 foot right there. Which is the least possible whole number, measure for the third side. So A is going to be 3 feet. B, so you have to choose between these answers. 5 foot and D, 10 foot. Let's discuss this now. Think about this in your head. You have a triangle now that has two sides, 3 foot and 7 foot. Which of these is a possible side, but also the least possible side for the third side? What do you guys think? Any suggestions here? Yeah.
Oh, least possible.
Least possible out of these choices.
It'd be 10 because 3 plus 3 cannot be equal to 10.
So 3 plus 7. What, so you're saying 3 plus 7.
3 plus 7 would be equal to, but it's not greater than.
It's not greater than. So you think it's 10 or you don't think it's 10?
10 would be least possible.
The least possible. So let's see. Okay. So Zane says 10 has to be the answer. So let's just double check. Let's see. What is the least possible number side? Okay. 3, 7, and 10. Okay. So you're saying that if we did 3 plus 7, right? Am I missing something here? If the two measures, what is the least whole possible number on the side? Is that greater than 10? Nah, so that doesn't quite work. But why? That's odd. Hold on. Must be greater than. Excellent. Determine the least possible side. So that's odd. Yeah, that'd make all the numbers not possible. So let's see. Oh, so actually, this 10 is not the answer then, right? It can't be the third side, right? So definitely 10 can't be the answer then.
Wait, but it says least possible in the thing.
Yeah,
So
but
10 is the
but it
least
doesn't
possible.
meet the requirement, does it? These two sides have to be greater than that third side. So is 10 even an option?
But that makes it the least possible to happen if it's wrong.
No, try the other sides. Let's try the other side. 3, 7, and let's do 5, right? Is 7 plus 3 greater than 5? Yeah. Is 5 plus 7 greater than 3? And is, let's see, 3 plus 5 greater than 7?
Yes.
So 10 isn't the least possible. In fact, it's not possible at all because that side is too big.
So it's not a triangle.
So that's not a triangle with 10 foot. That is not a choice. Okay? It's not cheating. Let's try it again. How about 3, 7, and 4? Would that be a real triangle at all? 3, 7, and 4?
That would,
Would that be
that's not also a triangle. 'cause
That's-
it's not greater.
also not a triangle? So it's not what you expect until you try these numbers out, right? How about 3?
That doesn't work either.
So let's do 3 plus 3. Is 3 plus 3 greater than 4? Yeah, it is. How about this one? 3 plus 4, is that greater than the other side, 3? And the other one's the same thing. 3 plus 4 is greater than 3. So we have two choices, 5 or A. But which one's smaller? 5 and 3, hold on, but which one is smaller though? We're looking for the least possible out of these choices here. Okay, so is 3. Yeah, this is not what I was expecting to happen. Yeah, Shamaria?
The last one you put 3, 3, 4. What happened to 7?
Oh, Shamaria. Thank you, Shamaria. I got ahead of myself. So let's see. 3, 7, and 3, right?
Yeah.
Oh, so let's do 3 plus 3. Is that greater than 7?
No.
So that's not even possible as well. So that's really the only choice. Did you guys like doing it that way, by the way? Yeah, you did? You like just going through? Because I was going to give you another way to do it that's more formal. Because in the future, what I might ask you to, instead of just giving you a list of choices, I might ask, can you give me a range of the numbers that it could be? Like all the possible numbers? And I don't know. I see David Sage. You're like, I don't know how to answer that question. How to find every single number, right? Okay. There's another methodical way to solve this problem, right? So I gave this to my other class, and they're just like, I don't know, but it just feels like C's right. Okay. But they couldn't find an actual way to do it. So let me actually show you the formal way to do this. Okay. So we have a hypothetical triangle. It's good to map it out. We have this 3, 7, and then we don't know what the third side is, right? We'll call it x, just like how we've been doing it before, right? So at this point, here, what do we know about 3 plus 7 in relation to x? Is it going to be greater or equal to x, or is it going to be less than x? It's going to be greater than x, right? What is 3 plus 7, by the way?
10.
So guess what? Our number, what does that say about our mysterious number right there?
Has to be less than 10.
It has to be less than 10. It can't be 10. We saw that. We tested that, right? We tested 10, in fact, up here. But I crossed out because we couldn't do that. So it has to be less than 10. That makes sense, right? Okay, what else do we know? 3 plus x has to be greater than which side?
Has to be greater than 7.
Okay, and now let's just solve for x. If I subtracted 3 from both sides, our number also has to be greater than what? Or what does that say about our number now? Our mysterious x number. Our mysterious number has to be greater than 4 as well, right? Let's just do one more condition. X plus, who else did I not add? What combination do I not have? I have 3 plus 7 is greater than x. I have 3 plus x is greater than 7. Which one am I missing now? Okay, and then to solve for x, let me just leave x by itself. I'll take out 7 from both sides, so I have x is greater than negative 4. So far, these are the 3 conditions for your number. X has to be greater than negative 4. X has to be greater than 4. X has to be less than 10, right? So it would look like this. X has to be greater than 4, also greater than negative 4, and also less than 10. It's sort of like this is our range of numbers. X has to be between 10 and 4. If you look back to our answers, our possible answers here, it's actually in your book here. Actually, let's go back to my question here. Which number is in between 4 and 10? C was, yeah. So if we do it this way, we can guarantee an answer here. And in fact, any number between 4 and 10 should work. 5, 6, what else am I missing? 4.1 would work. What else? 4.2. I could do, how about 7? Would 7 work? 8, right? But so far, I asked for a whole number. So I asked for the whole number. So you would say 5 in this case, okay? Could you do, let's do one more and then we'll call it a day. And then I'm going to put out one more video for a proof, okay? We're going to do one proof. I'm going to do this one here. Okay, this is going to be your example to work on. And there are 3, there's going to be a triangle here. 9, 13. I know that doesn't look like 13, but it is 13 centimeters. And n centimeters. You can also call it x if you want. Just don't be scared. It's n. I'm going to ask which of the following numbers could not be a value for n. Okay, guys, try to apply what we just learned to solve for, oh, sorry, let me give you the choices. A is F, or A is 7, B is 13, C is D, or 10, sorry. I'm all over the place. And D is 22, okay? 7, 13, or 22. Which of these 4 cannot be a value for n? Let's get to work. Let's try this out. I'm going to give you guys a few minutes, and then I will reveal the answer, okay? So work with each other, talk to each other about how to do this, okay? You may work on the board, right?
13 plus 9 equals 22. Okay, that's good.
Try doing it with the inequalities I just showed you.
I did. I accidentally solved it.
Did you?
Yeah, because I started with 13 and 9. It was greater than that.
Here's an added question. What is the range of values n can be? Now you have to give me the range too, right? So remember, if you try plugging in each number, you have to do all the combinations, which takes up a lot of time. Okay. So I would not suggest doing it that way. I would suggest going with doing the inequalities, setting up the inequalities. Like this. Let me help you out. N plus 13 has to be greater than what? 9, the third side. So if I subtracted 9, or subtracted 13 from both sides, I get n is greater than, what is it?
-4.
Let's see, minus 13. Okay. What else is another inequality I could set up? N plus 9. And then what now, Shamaria? Okay, and then now what do I do, Shamaria? And then what do I have now, Shamaria? Okay, so there's two conditions. That's awesome. Thank you. Anybody else? Can anybody else help me out with the last inequality I should set up?
You could just do 13 plus 9 equals n.
Is it equal to n?
Or greater than.
Greater than. Okay, so what's 13 plus 9?
22.
Okay, so what is my range going to be of values? What is n between? I'm sorry, basically.
4 and 22.
What are you going to say, David?
-4 and 22.
It's true. Could be between -4 and 22. But what does this say too? N has to also be greater than not just 4, -4, but has to be greater than also 4. So even though it says this is greater than -4, would -1 work, David? Well, does it fulfill this requirement? So be careful, guys. Do you guys see this here? That it's n's greater than two different numbers. Let's say if my n was 1, would that be a possible number? Yes or no? Why did you say no?
Because 9 plus 1 is not greater than 13.
Hold on. Don't do the math. Just follow by the actual conditions here. Why can't n be 1?
Less than 4.
Because it's less than 4. So the actual range, guys, always go with don't. So you're going to have a situation where you have two numbers here where it's going to be -4 and 4. Go with a slightly bigger number here. Your actual range, n has to be between 4 and 22. Because even though you pick a number that's bigger than -4, it still has to be greater than 4, positive 4. So your real range is actually between 4 and 22. Okay? So which of these numbers does not fall within that range? Is it A, B, C, or D? So here, D, okay, if I pick 22, if n was 22, that would not make sense, okay? 22 has to be greater than the number that n is, and 22 is not greater than n. So this is not an acceptable answer. So n cannot be 22. Does that make sense? All right, guys, that's the end of class. We're going to call it there, and then we're going to stop.